Hey guys, welcome to 5-5. It is my favorite section thus far in chapter 5, and the next one coming up is even better. So today you're just going to learn about rational roots and how to find rational roots. The word rational means that like they can be made into a fraction. You can do that little warm up if you want to, but we're going to just kind of run with it, and we're going to talk about this thing called the rational root theorem. Okay, so the rational root theorem is going to help you find roots of polynomials based on the leading term and the constant in the back. So let's take a look here. This is the leading term of this particular polynomial, and this is the constant in the back. So a solution means that it makes 0. All right. Now, there's a lot going on here, and there could be like a great big, like, I have no idea what just happened. Long story short is it does factor, and you can find it if you want to, but there's this really neat little trick that we can do. Okay, here it goes. Step 1, you find all the factors of the constant term. So see how the constant term is 10? So positive and negative 1, positive and negative 2, 5, and 10. 10 is divisible by all of those numbers. So you find factors of the constant term, and then you find factors of the leading term. So what does 21 divide by evenly? So 1, 3, 7, and 21. Then what you do is you take all of those different roots, okay, or all those different factors, so like of the constant term. So example, you put all of these and you divide by all of these, and whichever ones give you 0, those are the roots. Okay, so for example, if you were to take, so they're telling you negative 2/3 is the solution. If you were to take negative 2 and divide it by positive 3, you would get positive or negative 2/3. That's a solution. And if you were to take, what else do they have? Negative 5 over 7. If you were to take negative 5 and divide it by positive 7, that would make 0 on your calculator. So that would be a solution. Here are your steps in a nutshell. Number 1, make sure you set everything equal to 0. Divide all the factors of the constant term by all the factors of the coefficient of the leading term. Take every single answer you get from that step and see which ones make 0. So the ones that you substitute them in and they equal 0, the ones that make the polynomial equal 0, those are your rational roots. Remember, rational means it can be made into a fraction. So for example, not square root of 3. That's not a rational root. So it won't help you find the irrational roots. Now you will need to use synthetic division to find any other roots that aren't rational. And that is actually going to happen more tomorrow in chapter 5, section 6 than it does today. All right, I think it's going to be fun. Let's take a look. So all the rational roots, remember, this is not finding all the roots, it's just finding the rational roots. All right, take a look at this polynomial. Let's highlight it in green. It's already set equal to 0, so I can just like check. And it's time for us to see if we can find the rational root. So we need to find all the factors of the constant. Well, our constant is 5, right? In the back, you see how we have a constant of 5. And our leading coefficient, I'll just write leading and then that right there. Our leading coefficient is 2. So it says divide all the factors of the constant term by all the factors of the coefficient of the leading term. So what goes into 5? Well, 1 and 5, positive and negative of each. Well, what goes into 2? Positive and negative 1, right? And positive and negative 2. So I have to do, here it goes, I have to do positive 1 divided by positive 1. I have to do, let me see what else we have. Take every single answer and substitute. Okay, so that's the first one. I have to do negative 1 over positive 1. This reduces to 1. This reduces to negative 1. I have to do positive 1 divided by negative 1, which is the same. I have to do, what's the last one I didn't do here? Negative 1 divided by negative 1, which is positive 1. Now, you might say, hey, Miss Linda, do I have to do all of them twice? Like if I know I'm going to get negative 1 and positive 1 twice. No, you really don't. These ones here that I'm putting in the green box really weren't needed overall. Okay, so let's take a look at the 5 now. Actually, we still need to take a look at the 1. All right, so let's see. We did those ones. Boop, 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 boop. All right, so here's what I'm going to do. I'm just going to circle this like this, okay? We already did all of those. We did 1 divide by 1, positive and negative. Now it's time for us to do, in fact, you know, I think you saw what was going on. Here's what I'm going to do to shorten this up to make it easier on you, okay? Here you go. You saw like how long it would have taken? Here's a shorter way. You just do 1 over 1, positive and negative of that. And then you do 1 over 2, positive and negative of that. And then you do 5 over 1, positive and negative of that, and 5 over 2, positive and negative of that. That's just going to be easier overall. So it was 1 over 1, 1 over 2, 5 over 1, 5 over 2. So this means we're going to have this reduces to trying positive and negative 1. This reduces to trying positive and negative 1/2. This reduces to positive and negative 5. And this reduces to positive and negative 5 over 2. So here's all my possible rational roots. I'm going to write the word possible next to that. Now it's time, step 3, take every single answer, substitute them into the equation, and the ones that make 0 are your rational roots. So I'm going to grab my calculator and hope that that does exactly what I need it to. Put it over here, and I'm going to go to my y equals. My equation is 2x to the third minus x squared plus 2x plus 5, and I'm going to use my table on my calculator. I'm going to start with positive and negative 1. Positive 1, negative 1. Negative 1 made 0. Therefore, negative 1 is a rational root. I'm going to try positive 1/2 and negative 1/2. Neither of those made 0. So I'm just going to write no. Positive 5 and negative 5. Neither of those made 0. Positive 5 over 2 is 2.5. And negative. Come back. So those also did not make 0. So the only possible one that made 0 was negative 1. So we can say that negative 1 is a rational root. And you might say, hey, I thought there were 3 roots. Well, you're right. There are 3 roots because this was cubic, right? We should know that. This was cubic, so it should have 3 roots. It's just the other 2 roots are not rational. So they must be like square roots or something silly or weird like that. Okay? Now the last part, if you need to find all the roots, you would do step 5, but I kind of have that grayed out because we don't have to do step 5. You would do the same thing on number 1. I think I had that in a different video though. And I'm just going to write it is the only rational root. Okay, take a look at number 2. So we're actually going to do the exact same thing. So we have a polynomial right here in this red box. We have a polynomial and it's been set equal to 0 for us. Now it's trying to find all the possible rational roots. So this box is all the possible rational roots. On the homework, it asks you what are the possible ones, and then it asks you what are the actual ones. All right, so we're going to have to take our constant, and our constant in this problem, our constant in this problem is 2. And we're going to have to divide that by every factor of the leading term, the coefficient of the leading term, which is 15. So let's think, what goes into 2? Well, I know 2 and 1 go into 2. What goes into 15? Well, 15 and 1, 5 and 3. I just like to do them like that. That helps me see them. And positive and negative of each of those. All right, so let's list them out. Sorry about this. Ready? Here we go. Here are all the possibles. I'm going to shrink this down just a little bit. And here they go. You need to test in your calculator is 2 over 15, 2 over 5, 2 over 3, and 2 over 1. So we're going to test positive and negative 2 over 15, which does not reduce, positive and negative 2 over 5, which does not reduce, positive and negative 2 over 3, which does not reduce, positive and negative 2 over 1, which just reduces to positive and negative 2, And we need to try 1 over 15, 1 over 5, 1 over 3, and 1 over 1, positive and negative of each of those. Positive and negative, 1 over 15, positive and negative, 1 over 5, positive and negative, 1 over 3, positive and negative, 1 over 1, which is really just positive and a negative 1. Okay, lots of things to test. So remember, these are just the list of possible ones. Any actual ones I'll put in the box below. So I had to grab a different calculator because the cheap little calculator that comes with the iPad is not a good enough one. And you can see I typed this polynomial in my y equals up here. Okay, so just like your calculator at school, we're going to go to the second button and then we're going to go to the table button. And I'm going to type in what I want. So I wanted to try, I have to make this a little bigger. I needed to try 2 over 15 and negative 2 over 15. Neither of those made 0, so I'm going to put an X through them. Now on this calculator, I need to try 2 over 5. Nope. And negative 2 over 5. No. Now I need to try 2 over 3. No. And negative 2 over 3. No. If you're wondering, boy, I wish there was an easier way, the answer is no, there isn't. Now I need to try positive 2. Oh, there's one. Positive 2 works. Yay. And now I need to try negative 2. See how I got 0? Well, not on negative 2. I'll put a check mark on this indicating I tried it. Now I'm going to try 1 over 15. No. And negative 1 over 15. Remember, I'm trying to get 0. That's what makes it a root. Okay, X. I'm going to try 1 over 5. And now that didn't work. How about negative 1 over 5? Ooh, good. All right, I'll put check mark because I did it. Now I'm going to try positive 1 over 3. Yay, I got it. Okay, I'm actually going to stop there. I know I'm not even going to test anymore. Because this was a cubic, I knew I was only going to have 3 answers. That's like the maximum amount you could have. So all of these are the rational roots. They're not the possible roots. They are the actual rational roots. If we were to graph this thing and hit the graph button, that's where they cross. If I zoomed in here, that's where they're crossing. So you can see it crosses at all 3 of those points. I don't know how to like hit trace maybe. Yeah, see it crosses there, there, and there. And that's all the numbers that we came up with. All right, it doesn't ask us to find all the roots, just the rational, so we're done. I know I do the got it in the next video, so go ahead and follow that. Now it's time for me to teach you how to find additional roots. So this is a lot of jargon, and I would encourage you, if you can read math, to do it. But in layman's terms, here's what it says. If you have rational coefficients, like normal looking coefficients, like 2, 3, 3/5, something like that, in front of your x's, then all the irrational answers or all the irrational roots will have them occurring in conjugates. But all the rational roots rational roots don't have conjugates. So irrational and imaginaries have their conjugates, okay? So if they're complex, you use their conjugate pairs and vice versa. So you might be like, I have literally no idea what you just tried to say. Well, let's do it with an example. Okay, these 2 examples are super duper fast. A quartic, so 4 solutions, and x to the 4th problem. A quartic polynomial, an x to the 4th polynomial, has rational coefficients, meaning you can apply this rule. And they're telling you that square root of 2 is an answer, and 1 plus I is an answer. Those are all roots. Well, this is irrational, and this is imaginary, right? Those are kind of like weird roots. They're not rational roots. So what are the other 2 roots? Well, using this theorem up here, it means that their conjugates are also answers. So here's what we're going to say. Quartic polynomial, that means there's going to be 4 solutions. Given, you were given that the square root of 2 was a root. Is that irrational? Yes, it is. Okay, so I will write irrational, or I'll just write yes because it says is it, and we'll say yes, that's irrational. So what does that imply? It implies that the negative square root of 2 is an additional root. It's another answer. It's an additional root. All right, they also told you that 1 plus I was a solution. Is that irrational or imaginary? Yes, it is. What does that imply? It implies that its conjugate pair of 1 minus I is also an additional root. So let's apply that now to this got it. A cubic polynomial, so an x to the third, has real coefficients, so you can apply this law, or this rule, this theorem. Here are the roots. They are giving you this root, and they are giving you this root. And it says, what is another root? Well, this is the first one they're giving you. This is the second one they're giving you. They're asking you, what's the third one? All right, well, this one is rational. So we are not going to say that -5/2 has to be an answer. That's not a thing because it's rational. However, this one's imaginary, right? So the third root is going to be the conjugate pair of 3 plus 2i. So when it says what is the additional root, that's the additional root. All right, now we're going to use that to construct a polynomial function. Part 3. How do you construct a polynomial function given the roots? So I'm going to just walk you through it, and we're going to use this theorem up here. What is a third degree polynomial, p of x, with rational coefficients so that p of x is 0 if it has these roots given? This says that it's third degree, so I will need to have 3 factors, or 3 roots, or 3 zeros. They are telling me, in yellow, that x equals -4. Does that imply anything? No, it doesn't, because it's a rational answer. But it does mean that x plus 4 must have been its binomial, because if you solve for x, you would get -4. Next, in that pinkish color that I probably can't find, there, that's not too bad. They're telling you that 2i is an answer, right? So if 2i is an answer, that's actually going to imply quite a few things. That's going to imply that x minus 2i was a binomial, because if you solve for x, you would get positive 2i. Now, the next thing that we really have to gather is from this information up here. Since positive 2i is imaginary and it was a solution, that must mean that its conjugate pair of -2i is also a solution, which means that the binomial that it came from would be x plus 2i, because if you solve that for x, you would get -2i. So it's very important that you realize that this purple and this gray go hand in hand. So this polynomial would be made up of x plus 4. It would be made up of x minus 2i, and it would be made up of x plus 2i. Remember, this one was implied, and that came from this theorem up here, the conjugate root theorem. All right, now we have to distribute this together to get it in standard form. I will always encourage you to multiply the conjugate pair together first. So distributing together, I would get x squared plus 2ix minus 2ix minus 4i squared. That will become x squared minus 4i squared, because those cancel. And then this, you do have to remember from chapter 4, is really x squared plus 4, because I squared is -1. Then we're going to drop that little puppy down here, and we're going to distribute together. So we're going to have x to the third plus 4x plus 4x squared plus 16. The only other thing is I really hate that's not in standard form. So guys, we're just going to boop, 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 rearrange that so it is in standard form. And that is the polynomial that would have the roots of -4, 2i, and -2i. So these are the roots of that polynomial function. I'm going to move that because it looks super messy. There. Ooh. All right, 12:45. I have kids coming in. Descartes' rule, I'm going to just let you listen to the old school video of that because I just don't have time to get that through. But that's okay. One old school video is not so bad. What quartic polynomial has these given roots? Okay, so this one is a big deal. This says quartic, so I'm going to need 4 factors. Take a look at this first answer. How weird is that? They're telling us that x equals 2 minus 3i. That's weird. You know what that implies? I'll put it in blue since it's implying it. That would mean that x would equal 2 plus 3i because of that theorem I just taught you in the previous page. They're also saying that x equals 8, and they're also saying that x equals 2. So I have 4 roots here. Now it's time to set them each equal to 0. So if I took this 2 to the other side, it would be a minus 2. If I took that 3i to the other side, it would be plus 3i, and then that would show you like, hey, that's a root. So that means that this is in parentheses when I go to make my polynomial. It's my first one. Now if I set this puppy equal to 0, I'm going to have a minus 2, and I'm going to have a minus 3i. And that means that goes in parentheses because I'm working my way backwards. It's kind of weird. This would be x minus 8. This would be x minus 2. Yikes. And only because I know there's one in your homework similar to this, I'm going to work this one out just so you can see it. Okay, so we're trying, our end game is to get the polynomial equation. All right, so here it goes. The first thing is x times x squared, minus 2x. I don't want to mess this up, so I'm going to go nice and slow. Minus 3ix. All the weird things should go away. Now I'm going to do minus 2x plus 4. Take your time, Amy. Plus 6i plus 3ix minus 6i minus 9i squared. I need to get all of that put together before I even move on. That's going to be x squared. These are going to go away. These are going to go away. And this turns into a plus 9. So let's see here. I have minus 4x. I don't want to mess this up. And plus 13. So everything that I'm highlighting in gray has reduced itself down to this. Now it's time, let's pick a different color. Now it's going to be all this pink stuff. Okay, that stuff's not so bad. We can totally do that. That's a little bit more old school. Green. That's x squared. That one's easier, isn't it? Minus 2x, so much more comfortable. Minus 8x plus 16, which reduces down to x squared minus 10x plus 16. So the purple became the purple. Oof. I'm doing it because I know what happens in your homework and I want to make sure you're prepared for it. Okay, now we're going to put these two together. So I want you to notice what I did is I chose to put the conjugate pairs together first, and then I chose to put the other two items together, and now I'll put those resultants together. So that's x to the fourth, nice and slow because I don't want to have to redo this, minus 10x to the third, plus 16x squared, minus 4x to the third, plus 40x squared, minus 40 and 24, minus 64x. Okay, almost done. Gonna get rid of these arcs. Plus 13x squared. Oof, I should not be doing this without an answer key. Minus 130x plus, what is 16? I'm at computer. 16 times 13. 208. Okay, good. Oh, let's just hope I get it right, because I'd be really sad if I was wrong. All right, so I'm going to start with x to the fourth. That's always good. I did find my answer, by the way, so I'll know if I'm right. All right, x to the third. So I've got 10x to the third. That's negative 14x to the third. Good, that matches my answer key. I just found it. Now let's do 16x squared, 56x squared, 69x squared. All right, let's do one more. Negative 64x, it's negative 194x. Good, I didn't mess anything up. Plus 208. So that's my polynomial function that I would get if I was looking for those roots up there. So what would the roots be? The roots would be 2 minus 3i, 2 plus 3i, 8, and 2. So if you put this into your calculator, you will see it crossing the x-axis at 8, at x equals 8, and at x equals 2. You won't see them crossing here because those are imaginary, okay? Whew. And then I'm just going to use the old video to watch the Descartes rule.